Hello, my good friends. My name is TTJ Kepsi Richard, and welcome to my online tutorials. Today, our discussion on numerical and computational method will be on numerical integrations. We say when we come to numerical integrations, our attention is usually based on trapezium rule, Simpson 1/3 rule, and Simpson 3/8 rule. Please, today, before the video ends, our attention will be on Simpson 3/8 rule. I will indulge you to check out my videos on trapezium rule and Simpson 1/3 rule on YouTube. So with Simpson 3/8 rule, it says that when we are asked to find the area of a function, the area of a curve f of x, that's the integral spanning from a to b of the function f of x dx, and the table values of x and f of x are produced or generated as this. Then the integral spanning from a to b of the function f of x dx will be equal to 3f(h) bracket y naught plus yn. That's the first value of y plus the last value of y. Then plus 2 times all the values of y that are in multiples of 3 position. That's y3 plus y6 plus y9 in that order. Then plus 3 times all the values of y that are not in multiples of 3 position. That's y1 plus y2 plus y4 in that order. I hope you get that. So remember, the Simpson 3/8 rule can only be used if the number of vertices is a multiple of 3. And remember, our h is equal to b minus a all over n, where n is the number of vertices. So when the number of vertices is a multiple, or the n is a multiple of 3, then we can use the Simpson 3/8 rule. Other than that, we cannot use. So now we'll take some sample questions and see how we can put this into practice. So look at our first example. But before we do that, have you subscribed to my YouTube channel yet? If no, please do. It is the only way you can help promote my YouTube channel so that I can record more mathematical content for you. So the first example is saying that we should use Simpson 3/8 rule with 7 ordinates to evaluate the integral spanning from 0 to 6 of 1 all over 1 plus x squared dx correct to 3 decimal places. So how do we solve this? So the first thing we need to find is our interval of difference. Remember, we have 7 ordinates. Remember, we said we can only use Simpson 3/8 rule if the number of vertices is a multiple of 3. So number of vertices will be equal to the number of ordinates minus 1. So the number of ordinates here is 7 minus 1, which is 6. So you can see that 6 is a multiple of 3. Then we can use Simpson's 3/8 rule to do that. So our h, which is the interval of difference, remember, is b minus a all over the number of vertices. So the b, which is 6 minus 0, over the number of vertices, which is 6, 6 over 6 is 1. So the interval of difference is 1. So we'll construct a table values for x, where we start from 1 to 6, from 0 to 6, and the interval will be 1. So our table values of x that will start from 0 to 6, and the interval or the differences will be 1. So 0, 1, 2, 3, 4, 5, 6. And there are corresponding values of y. That's by substituting the values of x into this function. 1 over 1 plus x squared. These are the values we get. Remember, this becomes our y0, our y1, y2, y3, y4, y5, and yn. That's the last one. So the Simpson 3/8 rule, it says that the integral spanning from 0 to 6 of this function 1 all over 1 plus x squared dx will be equal to 3 bracket our y naught plus yn plus 2 times all the values of y that are in multiples of 3 position. That's y3 plus y6 in that order. Then plus 3 times all the values of y that are not in multiples of 3 position. That's y1, y2, y4 in that order. I hope you get that. So we have 3f. Remember our h is 1. Then our y naught is 1 plus our yn, which is 0.027. Then plus 2 times the value of y that is in multiples of 3 position here is 0.1. So only 0.1. Then plus 3 times our y1, which is 0.5. Our y2, which is 0.2. Then plus our y4, which is 0.0588. Then plus our y5, which is 0.0384. I hope you get that. So I'll add 0.5 to 0.2 to 0.0588 to 0.0384. We'll get 0.7972. And 3 will multiply that. So 1 plus 0.027 will be 1.027. 2 times 0.1 will be 0.2. And 3 times 0.7972 will give us 2.3916. And when we add 1.027 to 0.2 to 2.3916, we get 3.6186. And we'll multiply it by 3f, we get 1.3570. Then we can say that the integral spanning from 0 to 6 of 1 all over 1 plus x squared dx using Simpson's 3f rule will be 1.357, correct to 3 decimal places. I hope you get this. This is very simple. So we'll solve one more example on this so that you understand the concepts. So we'll solve our next example on Simpson's 3f rule. But before we do that, please remember to subscribe to my YouTube channel. If you are here too, this will make my YouTube channel grow more and I can record more mathematical content for you. It says evaluate the integral spanning from 0 to 1 of the square root of 1 plus x exponent 4 dx using Simpson's 3f rule with 6 vertices correct to 3 significant figures. So remember we said with 6 vertices. So since 6 is a multiple of 3, we can use Simpson's 3f rule. So we need to find the interval of difference h, which is b minus a all over n, where n is the number of vertices. The b is the highest unit point, and the a is the lowest, all over 6. So the interval of difference will be 1 over 6. So that means we start from 0 and be adding 1 over 6 until we get to 1. So our table values of x will be giving us, so 0, we have 1 over 6. When we add 0 to 1 over 6 to 0, we get 1 over 6. When we add 1 over 6 to 1 over 6, we get 1 over 3. We add 1 over 6 to 1 over 3, we get 1 over 2. We add 1 over 6 to 1 over 2, we get 2 over 3. We add 1 over 6 to 2 over 3, we get 5 over 6. We add 1 over 6 to 5 over 6, we get 1. So when we substitute all these values of x into this function, their corresponding values are what is given here. So Simpson's 3f rule is saying that our integral spanning from 0 to 1 of the function 1 plus x exponent 4 dx will be equal to 3f h times our y naught plus yn plus 2 times all the values of y that are in multiples of 3 positions. That's y3, y6 in that order. Then plus 3 times all the values of y that are not in multiples of 3 positions. That's y1 plus y2 plus y4 in that order. I hope you get that. Remember, this is our y0, this is y1, this is y2, y3, y4, y5, and this is our yn. Then we can say this will be equal to 3 over 8. Remember, our h is 1/6. So that was the interval of difference, 1/6. Then times our y0 is 1 plus our yn, which is 1.4142. Then plus 2 times the values of y that are in multiples of 3 positions. And the only one here is 1.0307. Then plus 3 times those that are not in multiples of 3 positions. That's y1, 1.003 plus y2, which is 1.0061 plus y4, which is 1.0943, then plus y5, which is 1.2174. So when we multiply 3 over 8 by 1 over 6, 3 will go into 6 twice, so we'll get 1 over 16, then bracket. So add 1.003 to 1.0061 to 1.0943 to 1.2174. We'll get 4.31261. So our 1 plus 1.4142 will be 2.4142. And 2 times 1.0307 will give us 2.0614. And 3 times 4.31261 will give us 12.9378. When we add 2.4142 to 2.0614 to 12.9378, we'll get 17.4134. And we'll multiply that by 1 over 16, we'll get 1.0883375. So we can say that the integral spanning from 0 to 1 of the function 1 plus s exponent 4 dx will be equal to 1.088, correct to 3 significant figures. I hope you get that. We'll end it here today. Please remember to subscribe to my YouTube channel before you sign out. Until we meet again, my name is Kepsi.